Now we're back. So for our second example, we're gonna do now the OR logic gate, which just basically means it's two transistors and it only requires one. You don't need both transistors to be activated. They're like in parallel. In the previous example, they were in series, but now they're in parallel, which means in this occasion, it only requires one to be active. You can also both can also be active, but like this one's also like a minimum require of one, and the system will be still running. So start again. We have our breadboard again, blank. So we only have the positive and negative connector to start with. So once again, we'll place our transistors right here, but this time we're gonna place them in parallel to each other. So what do I mean by that? They're not gonna be in the same row. They're gonna be in separate rows, and the cables are gonna be along each other, so they match. So that's how it's gonna look. I'll use the okay. Let's connect our LED. Let's get it ready. There you go. So now we use I'm using my blue cable, as you can see, right there. Once again, these two facing away from you. Now we'll use our blue cable to jump from this side of the breadboard to over here to power it, the whole current. Same thing, place a resistor below right here with the positive side, make a jump to our transistor so it collects the current. It's right there, plays now. Okay, so now this is where breadboard changes. As you can see, the placement is different because our cables are gonna be differently in place. So I'll use the red one. One point to the collector, another point also to the collector. Right there, as you can see, they're both in the collector side. And now I'll use a blue cable for the emitter from one transistor to go to the other emitter. So they're both ends connected by the cables. So this is how it's looking. Okay, now we need to connect. Now we'll connect the second emitter. We'll connect it to our LED right there. So they're like alongside each other for current to flow. Once again, so this is how it's looking so far. And this is gonna act as a switch. So right now, we're just consisting of one switch. So this is like our switch. So let's connect our battery source so we can get current flowing. As you can see, it's on. So right now it's off because my switch for both sides there, it's off. But this time we're just gonna use one switch, which is gonna be the white cable. It's gonna be acting for us. So I'm just gonna activate for one side. So as you can see. So in theory, this should turn on. There's one input, not the other one. See, as you can see, this is, as I mentioned, we have one switch on, so current is flowing in this side instead of the other side. Since this side is blocked, it's only path flow is this side. And it should work the same if I disconnect this switch and now place it to the other transistor. It should behave the same way. Current is not, see, now current is flowing this side of the board. If I get, and now if both sides are connected, if I activate both switches, in theory, it should work the same. There shouldn't be no problem. So, yes. As you can see, both switches are on. It's flowing. I disconnect one switch. It's still flowing because the path is going this way. And if I disconnect this one, zero path since there's no connection. But once again, only one requires to be activated. Yeah, that's how OR logic gate works. And now we'll go to the NOT gate.